So we have a new integration technique today. It is called integration by partial fraction decomposition. Doesn't that sound fun, Annie? No. That's two. Come on. So, is it difficult is usually the question I get. Oh my gosh, this shield is so dirty. Is that you, Mother? I can't say anything. I kind of can. It's not that it's difficult. You just have to be careful with your algebra and your signs. But the process is pretty slick and it goes pretty well. Again, as we continue to get more and more techniques, don't forget that with one like this, what should always pop into your head first is U-Substitution. Okay? So, this is actually in a, what I call a trigger form for using partial fraction decomposition, but U-sub works, and U-sub's king. So if you use x squared plus 10x, because you're going to, now that you learn a new technique, you're going to look at this one. You'll see why once we do a couple, and you're going to go, oh, decomp. I'm going to say, no, it's an old one. This is U-sub, right? I'm now sitting there with U right here. My du dx is 2x plus 10, correct? So if I were just to take a half of it, I would have the rest of the integrand. So be careful, and again, you know this is AB 101, but now I have 1/2, and the rest of the integrand is du. What does this one pass off to? Natural log. And decomp almost always, if not always, passes off to natural log as well. So they're a little, hi.
Sorry to interrupt. I just need Maya for like 2 minutes.
She's back in the corner. People do put baby in the corner. Name that movie?
Hi, come on now.
Dirty Dancing. Girl, I knew I liked you. All right, so this could be done with just general U-sub because the derivative of the bottom lives as a multiple on the top. And we've done that a lot, right? But if you tried that on this one, and you still should, in your head you should go, oh, 3x plus 3. And had there been some multiple of x plus 1 on the top, we're good to go with U-sub. But there is no way I'm getting 8x plus 82 from 3x plus 3, don't you agree? So that's a failure. So when that happens and they're set up like this, you might say, like, what? We're going to call it down here. When they're set up, so that, I'm going to go show you the page where there's some homework on it so you can see it. I'm going to go where there's some samples. Take a look at this guy. U-sub, U being x squared minus 6x plus 5, du is 2x minus 3. I can't generate the top. But do you see on the bottom, I can factor it, right? So if I were to go and factor this one, x minus 1, x minus 5, we call those non-repeating linear factors. You get why, right? They're linear and they don't repeat. Partial fraction decomp can be used for, I'm going to go back a couple pages. If I were teaching this in college, we would cover all of these situations. But College Board only does non-repeating linear factors in the denominator for testing, and it's not because they want to make it easy. The other ones are just so similar, and there's just more you'd have to memorize. So we'll deal with that maybe after the AP exam. They're not more difficult, it's just they're in a different form, so, but it still lays out. So they always just restrict for memorization purposes because you can't use a note card. They just promise us in their thing that it always says non-repeating linear factors. This would have a repeating linear factor. It's not that you can't do it with decomp, it's that we're not going to now. All right? And this would be considered non-repeating, x minus 2, x minus 3, x plus 5 linear factors. Does that make sense? What they mean by non-repeating linear factors. When you see that in the denominator, your brain's going to go decomp. But the question is, do you remember how to decompose fractions from pre-calc? Maybe, right? So it might ring a bell. It might not, but I'm going to give you the framework for it. So I'm going to give you one that's decomposed. By decompose, it means broken apart. So I've got one that's decomposed. I'm going to put it back together. When we add these, I've always told you crisscross applesauce, correct? When we decompose, it's actually uncrisscross applesaucing. It's the reverse. But we're going to work forward. So we would say this is 2 times x minus 5 on the criss, plus 3 times x plus 2 on the cross, all over, multiply across. If we were just having to add fractions, you're basically getting a common denominator from Algebra 1. Then, when I clean up the top, I have 2x's and 3x's for 4x's. You might say, what does this have to do with integration? We're getting there, all right? And I'd have a minus 10 and a plus, where did I get, I should have 5x's, right? 2x's plus 3x's is not 4x's, it's 5x's. And then I'll have a minus 4, looks like. Are we good? Did I lose you yet, Annie?
No.
Nope. Well, now what we're going to do is say, well, what if you were presented with this, don't write this in your notes, in an integrand? As it stands, I have, and it might have been x squared minus 3x minus 10 on the bottom, right? U-sub wouldn't have worked, and you would have been stuck. But if you knew how to work backwards, that's called decomposing, breaking it apart to what it originally was, uncrisscross applesauce, then you could integrate it in your head, hopefully, right? Are you nodding? What's the antiderivative of 2 over x plus 2? You should know that one, right? 2, natural log, absolute value, x plus 2, right? Plus 3, natural log, absolute value, x minus 5 plus Carl. So we're going to keep the integration off of it at first because I think I probably need to review pre-calc. How do you decompose a fraction? Unless you tell me, no, I know how. We need to. Okay, great. I was planning on it, so I have it built in. Usually every year then they go, oh, it's that? But then they still are like, God, I did it so long ago. All right, so now we're going to take this, and it might have been written with a quadratic in the denominator, and maybe you had to break it apart with some factoring, and we're going to go back and figure out how did it become a 2 on the top and a 3 on the top. And here, there's 2 ways. I'm going to prefer you to use the second way, but I'm going to teach it the way I think you showed it in pre-calc. And then I'm going to show you a way that works kind of nicer for this situation. So let's go up here, and we're going to take that 5x minus 4. Sorry, I lost it. So, and we're going to decompose it. I already know what I'm going to get. So it's a 5x minus 4 over, can you remind me what it was on the bottom there? It was an x minus 5 and a plus 2, right? All right, boom. This is called non-repeating linear factors. I'm going to go back to that blue chart and show you. I clipped this out of a college textbook. Might even be out of our book back there. But do you see how it says you put the x minus a on one and the x minus b on the other? That's unapplesaucing, right? You multiply across, well, you're going to break it apart across, all right? On the top, you'll notice that when we're linear on the top, we go to constants. And we're only going to deal with non-repeating linear. So when I go take, boom, boom, let's move on down here. All right, so when I break this apart, I'm going to say I'm going to unapplesauce you. So those got multiplied across. I am going to undo it, right? I always would go criss plus cross over multiply across. I'm undoing that. It's going to be some number and some number. Now, the way that both methods start, technically in a textbook, it's going to say to multiply through everything through. You're going to come up with a little shortcut to this. Basically, get rid of the fraction part of it. So you're going to multiply everything through by x plus 2 times x minus 5. So you can wipe out those denominators. Perfectly legal as long as you do everything through by it. So what you end up with is the top of the fraction on the left becomes Chris plus cross. Do you see the uncrisscross applesauce of it? So the top of the fraction becomes the Chris plus the cross. So you really don't need to do what a textbook tells you to do if you kind of think of it as uncrisscross applesauce. This plus this had to equal the top of the fraction, right? And then it's all over applesauce. So it's undoing it. Now, the way a textbook normally teaches this is they'll do something that's called correlating the coefficients. So we're in search of the A and the B. So what we'll do is distribute the A in. Is this ringing a bell for any of you? Okay, we're going to go to a different method in a little bit because it's just a little bit more user-friendly, but this is how it normally gets taught. Or some of you kind of going, yeah, I think I did that about 2-3 years ago. So what you do is you grab a hold of your x's over here, and you sort of think of combining like terms. So we're going to rewrite this, and I'm going to show this first one with all of its steps. Okay, so I'm going to rewrite those first. Right? And then over here, I would have 2a minus 5b for the constant part of it. So I'm going to go grab a different color. Right here, right here, right there. I'm going to go grab a different color, maybe. There we go. So this 2a and this minus 5b, I'm putting down here, right? It's going to have to go with the minus 4. These two things are equal. So it's kind of like this had to equal that. So you know that a plus b, what does a plus b have to equal? 5, right? You could write it as a plus b times x, but it's got to equal a 5. So you're going to write 5 equals a plus b. By the way, does it? Because we know the answers. Go back and look at the original constants on the top. They were a 2 and a 3. Do they add up to 5? Yes, but so does 1 and 4, right? So does negative 10 and 15. So that's not, I'm not concluding from this that it's 2 and 3. But I also know that this constant, this negative 4, had to be the rest of that. How are we doing? So basically, you've got algebra 1. Somebody asked if it was easy today. The calculus of it's super easy because it always passes to natural log. So it's nice. But there's a lot of like arithmetic and algebra in it. So now I have a system of 2 equations, 2 unknowns. Back to algebra 1, right? Haven't done this for a while, but what do you do to solve 2 equations, 2 unknowns? You either use substitution, which I rarely use, or combination method, right? So I'm going to multiply the entire top through by, either 5 to get the b's to cancel or negative 2. I'm going to go with negative 2 just because. So this is kind of boring right here because this is just algebra 1. So it's kind of when things pass to decomp, you're kind of going to go, oh yay, it's decomp. Even though there's lots of stuff up here, it's easy stuff. So I end up with this, negative 14 equals negative 7b. Correct? So what's b? What a shocker, right? It's 2. Let's go back up all the way to the top, all the way to the top. 2, right? 2. See how it matches? And then obviously if a plus b has to equal 5, right? My b has to equal 3. What do you think? So we worked forward by crisscross applesaucing, and decomposition is really just uncrisscross applesaucing. All right, so now I told you I am going to teach you another way that's a little bit more user-friendly. I call this method strategically choose x. It starts off the exact same way though, so I'm going to go kind of fast. It starts off by saying, we're going to break this apart. We're going to applesauce. Decompose that denominator. Then you put constant, constant. I know I'm going to get 2 and 3. I'm just going to get it a different way. Okay? Now, if there were 3 linear factors, then you'd have plus c over the third one. Or 4, then we won't go more than 3 though. They just get messier. All right, so then I'm going to say that the numerator came from Chris, boom, plus cross. It starts off exactly the same, and this is where it goes different. And every year, almost everybody, every once in a while, one person who sticks with the old way. That's totally fine. Most people prefer this way. So I'm going to strategically choose x. I'm going to pick it so that it wipes this chunk out. This equation's true, right? So I'm going to let x equal -2. Watch what happens if I do that. When I put it here, I'll get a -14 equals. It'll wipe this sucker out. You strategically chose it to kill it off. And when I put it over here, I get -7b. What's b? That was a little, wasn't that a little more user-friendly? I think so. What do you think when I say strategically choose x? My other choice is going to be? What do you think? 5. Yeah, to get that to wipe out. Oh, you can't see me in the video. To get that piece to wipe out. If there was a third one that had c times x minus 7, we're going to choose 7 to get a 0. You want zeros. That's why I call it strategically choosing. All right. So when I go put a 5 in here, I get 21. When I put a 5 in here, I get 7a, and out pops a, b, and 3. A little bit more user-friendly. Okay? So I like that. And now that it's easy, once it's decomposed, you can integrate it. So really my original was 5x minus 4 over x plus 2 x minus 5, correct? I'm just going to make 100% sure I've got my signs right. I think I do. X minus 5, x plus 2, yes. Dx. So now had it been in an integrand, and again, I might have been in there as x squared minus 3x minus 10, but if you look down and you go, I can factor that into linear factors, decomp is your guy, okay? So now that I broke it up into something over x plus 2 plus something over x minus 5, which one was the 2? Was it here? This one was the 2, wasn't it? Yep, you're nodding. This one was the 3. Now not only can I integrate it, I can do so really quickly. So most of the work comes in non-calculus stuff for decomp. Because now, if u is x plus 2, du is 1, this is 2, natural log absolute value x plus 2, plus 3, natural log absolute value x minus 5, plus my good friend Carl. So the work to go from here to here is where the work is. All right, what do you think, Ian? Can you do it? I'm going to caution you to be very careful if that had been a 3. Why wouldn't this just be a 3? What do you think, Bodie? Fraction correction. Yeah, for U-sub, I'd have 1/3. So keep in mind, always check for U-sub first, because U-sub still came. The denominator must be for these higher in degree. A higher degree. I didn't leave much space to write that. Then the numerator. And we are only doing this for non-repeating linear factors. And you may need to factor first. So now we have a new integration technique in town. We're going to go practice it. So from here on out, you're going to look at that, and what's your brain going to try to do really quickly? U-sub, and it fails. And then you look and you go, oh, I'm stuck. Long division. That's not a candidate either. Because for long division, the degree on the top has to be greater. You have to be able to divide the bottom out of the top, right? So this one, you're going to go, maybe I can decompose it. And then the minute that denominator factors, you're like, this is probably my winning candidate. So we are going to be decomposing this into something over x minus 1 plus something over x minus 5. The minute I have the somethings, it passes to the natural log super fast. What do you think, Harvey? So this is our first one. We're going to go find those somethings together. Okay? If these are equal, then the numerator had to equal. It comes from Chris plus Cross. And then it was all over applesauce, but I don't care about the applesauce because I can see it. Correct? Now I'm going to strategically, Mason, choose X. Who am I going to let X be? I'm going to let X be 5. I'm then going to go plug it in right here. I'm doing the second method because I like it better. If you like the first method better, you go ahead and use that. It's going to kill off this one, and it'll be a 5 here. So I end up with 1 is equal to 4b. Be careful that you don't write b equals 4. That happens all the time when it's a fraction. So be careful that your b is 1/4. All right? The other thing to be careful of is make sure you put it, just because we found it first, don't put it on top of the first part. That's the b. So that'll become a 1/4. That was fast. Right, Daniel? And not difficult. Do you think kids usually complain about decomp? Not really. Or by parts, unless they're as ugly as that worksheet number 4 was. By parts, we usually don't complain about either. Next, I'm going to let x equal 1 to kill off a factor over here, or a part of the sum over here, and get me down to 1 variable. So I have a -3. I'm going to put in a 1. And I'll have, a -4a. Am I going too fast? This is not even calculus right now, so you should be just fine with it. So my a is 3/4. The minute I decompose it into its pieces, the calculus goes really smoothly, right? It's set up perfectly. If u is x minus 1, du is dx, that's 1/u du, but there's a 3/4 in front of it. So go ahead and tell me what the answer is. Let's go with Daniel.
3/4 ln absolute value.
Perfect.
X minus 1 plus 1/4 absolute value, or ln absolute value.
That sounds ugly, doesn't it? And you can't, and don't forget Carl, right? So you couldn't hear him on the video. 3/4 absolute value x minus 1 plus 1/4 absolute value x minus 5 plus Carl. Beware if there had been, again, I'm just going to say beware that if you're doing that U-sub in your head, which at this level is recommended, beware of that, beware of that. Right? Because then it would be 3/4 natural log absolute value -7x minus 1, but we would need a -1/7 correction on it. So beware of that. You go, Tyler. And then I think I just have one other, a triple denominator. Yep, and then that's it for today. We'll save. We're on this for 2 days, I think. They're working on it on their own, you people at home, and you should too. I'm just going to start writing it to save some time. Felt like the yellow. that far? Most of you are looking up right now, right? Got a little uglier because of the fractions. Don't worry about it. B being -1, how many of you got that to fall out right away? Pretty nicely, right? Over here, strategically choosing letting x equaling 3. When I had to let x equal -1/2, remember you want to kill this off. Be careful when you plug it back in with the arithmetic, right? A -1/2 minus 10 is -10.5. You can see me kind of working with it over here. I like improper fractions. I don't like that they get the name improper because they're my favorite. I'd rather deal with an improper fraction than a mixed number. Anyway, when I plugged it in over on the right, I had a -3/2 left. 2, right? Are we good? Is that not right? What am I plugging in here again? You guys are looking at me funny. Oh, sorry, it's in over here. Yeah, sorry. And that should be an A. Sorry, I plugged it in on the, I wrote it, but that should be an A. All right. So when I have my -1/2 minus 3, my -7/2, right? I goofed up. Watch your arithmetic. I was going fast and screwed it up. All right, now, when you solve this, last year I remember seeing a lot of people setting the cross products equal, which is totally valid and will get you the right answer. But if two fractions have the same denominators, their numerators have to be equal. So you can kind of just do it in your head. What's my A? A is 3, right? So now make sure you put it with the correct one. Boom. And now be careful with your answer, right? I'm stressing that more this year because there was one on a practice test where a college board did that and kids forgot the fraction correction. So I'm like, I got to drill that in more. So this would be 3, natural log, absolute value, 2x plus 1 with a fraction correction. Did you remember it? So 3/2. All right, you guys got it? It's kind of easy. They're all nodding, those of you at home. So now what? Again, it's just all algebra issues. Do you remember your algebra well enough to break this into, again, U-sub's a colossal failure. It certainly isn't a candidate for by parts because it's not incompatible functions or anything I can even break apart. If it was upside down, I'd have a heart and I'd break it apart. So do we remember how to break apart a cubic? Some are nodding and some are shaking their head no. So it's like a 50-50, I think. What were you going to say, hon? Yeah, you can do this one by grouping. And if you forgot what that is, okay, that's back to algebra 2. You group the first two together and pull out an x squared. You group the second two together and pull out a -16. And you hope that that piece in there is the same. By that, I mean the x plus 2. All right, Katie, so you said it. Do you remember what you get then? Yeah, it's x squared minus 16 times x plus 2, which makes sense because if you distribute this in, you'd have x squared times x plus 2 minus 16 times x plus 2, right? So it works nicely. So she said x squared minus 16 times x plus 2, no calculus in that. But I can only have non-repeating linear factors, so this works out nicely. And now it becomes a perfect candidate for by parts. Bam. But on this one, you have to be careful with thinking about it as uncriss-cross applesaucing. That's great when there's only 2. How many do you think College Board usually has for their non-repeating linear factors? 2. Because adding a third just makes it take a little longer. All right, it just gets a little messier. So let's go decompose the fraction. So you're going to say x over all that stuff, and I am going to rewrite it. I'm decomposing this so that I can pass it off to natural log. It's going to equal something over the first factor plus some other constant over the second factor. Let's call it b, plus some other constant over the third factor. But because there's 3 of them, you can't really think of it as the uncriss-cross applesaucing, but you sort of can. You're really going to multiply the whole thing through by the denominator, and it's going to kill it off on the left. And on the right, if you were to multiply this by the denominator, the x plus 4 would kill off. So you really get a times the other 2. You see what I mean? So it is sort of still. And then b, you'd have times the other 2, because x minus 4 would kill off. Some teachers make you multiply everything through by the LCD, but if you can just picture it, it's pretty easy. So you do b times x plus 4 times x plus 2, and then Mason, I already called on you today. Who did I call on today? Noah, what will I multiply c by? X plus 4, x minus 4. So you guys go find the a, the b, and the c for me by strategically choosing x values that cause zeros. And you're going to be choosing 3 of them. Did I write something wrong? C, x plus 4. So you're going to be letting x equal, and letting x equal something else, let x equaling something else. Each choice will kill off 2 of the others. Those of you at home, they're finding me A, B, and C, and you should be doing the same. And when they are done with it, they're going to tell me. No fraction correction for any of the antiderivatives. And if you could put your pencil down when you're done, I'll find worksheet number 6. Hopefully. A, B, and C, right too small. Same fractions. Are all 3 of them fractions? Yes. Can I steal Witter's? You guys can tell me if she's right. Witter, what'd you put over your x plus 4? Notice I didn't ask you what your A, B, or your C are because it depends on your order.
-4.
Can anybody concur? Yes? Lots of knots. All right, and what went over your x minus 4?
112.
112? Yep, Catherine's nodding. And what went over x plus 2?
16.
You guys agree? Okay, these are all perfect for passing to natural log, no fraction correction needed. So negative 1/4 natural log absolute value x plus 4 plus 112. Natural log absolute value x minus 4 plus 1/6. Natural log absolute value x plus 2 plus Carl. It looks ugly, right, Noah? But the process isn't very difficult. So your homework for today is just 1 through 10 on here. You'll notice that, first of all, I do this on a separate sheet of paper, because as you can see, and when you write so tiny too, it's hard on my eyes. But be careful with one like number 9 and 10. Because when I asked how to factor a cubic, and Katie said by grouping, that was the exact answer I wanted for that cubic. But not all cubics result in having that same factor, like on number 9. So I'm hoping they can still hear me. I'm pretty close to my computer. But do I ever go really soft on the videos? That's when I'm usually moving away. I don't like to wear my headset and my shield and my mask. All right, so go look at number 9. We're going to troubleshoot that one because it is going to be one where you're going to go, how do I do that? You're going to go look at the key. Because if I tried to do it by grouping on number 9, I'd pull out an x squared and have an x minus 2, plus 2 I mean, and the other part doesn't even factor. So by grouping is a method if you get that same grouping, right? But now what? Somebody else has to dig way back into their Algebra 2 or Math Team days or something to come up. You loved it when you did it because it was super cool how it worked. But somehow, who said that? Catherine. You couldn't hear her. Did you guys hear what she said? Synthetic division. Wow, where did you pull that from, kiddo? Usually I have to like say, it rhymes with quinquetic or something. And so I go, oh, I know. Right? Yeah, where did you pull that from?
Said it was fun.
Oh, because I said it was fun. I know most kids love it because they're like, oh, you just do this and this and this and oh, voila, it works. But you got to remember what you do. The first thing you need when you do synthetic division is 1 0 or one factor. And usually in Algebra 2, they give it to you, right? They'll say x minus 1 is a factor, and then you use a 1 here. Or they'll say 1 is a 0. When you don't have it, you have to find it. But usually it's nice if you don't have a calculator on which to graph it, which we're not using a calculator. So usually it's 1, 2, -1, or -2. Those didn't work. I maybe tried 3, -3. But usually you can find one in your head by just toggling. Like, I'll try 1. So let's try 1 and see if that poops out a 0. 1, 1, 1. I would have 1 plus 2 is 3. That's not going to work, right? What would be the next one I'd probably try? Again, I'm trying to find a 0. Give me another number to try. 2, let's try it. I'd do 2 cubed plus 2 times 2 squared minus 10 minus 6. Does that give me a 0? Right? So if 2 gave me a 0, one of my factors is x minus 2. Wouldn't you agree? Like, has to be. So I found one of my 3 linear factors because there's always the number of power. So we put a 2 here. Now, Catherine, you said synthetic. You said you liked it. Do you remember what you did? I'll remind you. You grab the coefficients of the entire polynomial. You draw a line. Anyone can talk me through it? Is this ringing a bell? What do you do with this 1? Drop it. Then you multiply this times this, add it up. Multiply this times this, add it up. Multiply this times this. Oh, positive 3. I was like, that actually is going to give me what I want to tell you next. If you don't get a 0, it wasn't 1. Okay? These aren't negatives, these are me pointing. So anyone need me to repeat that? We're good, right? So how is this now helpful? I just knocked it down a degree because I'm pulling out an x minus 2, right? So I pulled an x minus 2 out of it. This tells me the remainder that knocked down a degree is x squared plus 4x plus 3. And that I can factor in my head. So x plus 1 and x plus 3 are your winners. And I don't remember what was on the top of that. Catherine's the winner for the day for synthetic division. Thank you. All right, have at it. I think that only happens maybe on number 9. But I remember from last year, I got a lot of questions on that one. Somebody who gets the answer to number 1, go ahead and tell me what it is. I'm going to stop the video.